Alright, welcome to the first note set on Chapter 1. We're going to look at variables and expressions in 1-1, and then we'll look at order of operations in 1-2. So this is going to probably go pretty quick. Most of this is review, things we already know, things we're good at. So it's a nice place for us to start. While we are comfortable with this, and these are things we're good at, I will tell you that up all the way through calculus, the most errors and mistakes that we see as math teachers are in the simplest of things. So making sure that we're writing and understanding verbally and algebraic expressions or simplifying them, and then order of operations stuff, we see errors in that everywhere. So just make sure you concentrate on the simple stuff. So writing a verbal expression, we need to be able to take something that is given to us as a problem, like any of these, or just as an expression with variables, and we need to be able to write it out in words. Okay, this goes over things. You guys know terms like factors. Those are two quantities being multiplied, and the result is a product. You guys know that when we raise something like this, we have a power, and the little number is called an exponent, and the big bottom number is called the base. You guys know all of that stuff. So example 1, write a verbal expression for each. We just need to find a way to say this and exactly this. So there's a lot of different answers here. 3 times x to the 4th power is an easy way to write that out as a phrase. And over here, 5z squared plus 16, that's written out as 5 times z to the 2nd power plus 16. There's a bunch of different ways you could write these. Take a second, pause the video, try and write out a verbal expression for 1a and 1b, and then we'll check them. Pause the video now. Okay, let's see how we did here. This one, I very simply wrote that it's 16 times u squared minus 3. You might have it written differently, and that's fine. If yours is different and you're not sure, make sure you ask in class if your answer would be correct. Here I wrote the sum of 1/2 of a and the product of 6b, that's a b, divided by 7. Now, are there other ways to write this? Absolutely. There's plenty of other ways to write this. That's just how I wrote it. Again, if you're not sure if your answer is correct, best thing to do is put a star or a check next to it or something and talk to me about it in class. Make sure that you have an answer that will work for us. The next thing is we have to, in writing algebraic expressions, an important skill is translating verbal into algebraic. So this is more useful like for when we have a word problem and you're told some things. And so it's the same thing we just did, just moving in the opposite direction now. So a number t more than 6 is going to be 6 plus t or t plus 6. There's words that we should recognize, by the way. Let me just highlight some of these real quick. We want to make sure that when we see some of these words, we think the things that we're supposed to. So, more than, some, plus, increased by, added to, those are all ways to say addition. Less than, subtracted from, difference, decreased by, minus, those are all ways for subtraction. Product of, multiplied by, times, and of for multiplied, and then quotient of or divided by for division, okay? And then, of course, you guys know that is equals if we have an equation. But so here we're just taking what they tell us. 10 less than the product of 7 and f. This is probably the most commonly missed one because the 10 is first. Students will often put 10 minus 7f, and that's not right. It's 10 less than that. If I tell you I have, that Dr. Bishop has $20 and I have 5 less than him, to know how much I have, you're going to do 20 minus 5, even though I said 5 less than how much he has. You just have to make sure that the grammar matches the math, actually. So 2/3 of the volume V would just be 2/3 V. You can write this like that or that. They're both correct. Okay. Take a second, pause the video here, see if you can get some answers for 2A and 2B. Go ahead and pause the video now. Okay, so you've unpaused. Let's walk through what we got here. Very simply, 2A, the product of P and 6 is just 6P. I guess you could write, P like 6, like that. We want to get out of the habit of using the x and the dot. We don't want to use those anymore for multiplication just because it'll get confusing. 1/3 of the area A, that's really simply 1/3 A, or you could write A over 3. Okay, either one of those is correct. Let's take a look at a real world example over here in writing a written expression. They give you the example of Mr. Martinez orders 250 keychains, 500 pencils, and then we want to know the cost. So the cost for the keychains is K, the cost for the pencils is P, so 250K plus 500P. Very simple stuff here. The coffee shop problem right here, Katie estimates that 1/8 of the people who order beverages also order pastries. Okay, so 1/8 of the order. Write an algebraic expression to represent this equation. So 1/8 of the people who order beverages also order pastries. So we have all the beverage people plus 1/8 of the beverage people to get to the pastries. Okay, that would be all of the people total. If you just wanted how many ordered pastries, it would just be 1/8 B for beverages. Okay, pretty simple stuff. Order of operations. So we're going to use terms like evaluate for algebraic and numerical expressions using the order of operations. Again, this seems simple, and I know you guys know this stuff, but it isn't. This is where a lot of mistakes happen. So sometimes we're just very asked as simply as we can be to evaluate something. That's just like calculate. So, 3 to the 5th means 3 times 3 times 3 times 3, so that's 243. These would be a perfect example of problems that you don't want to use your calculator for because you're probably not going to get to use your calculator on the SAT or PSAT when you take this section, these kind of questions. So pause the video right here, try 1A, 1B, and 1C yourself. Go ahead and pause the video. Okay, you've unpaused. Let's take a look. 2 to the 4th. Well, that's 2 times 2 times 2 times 2. So that is 16. Okay. 4 to the 5th. This might be a little bit harder for you, especially without a calculator. You could think of it, just do them one at a time. 4 times 4 is 16. Times 4 is 64. Times 4, you might not be able to do that one in your head. I can. It's 256. And then times 4 more. So that's 4, carry the 2. 2, carry the 2, so that's 1,024. And then 7 cubed is 49 times 49 times 7, so that's 343. Okay? Easy stuff. Order of operations, you guys know. Hopefully most of you at this point are learning not PEMDAS, but GEMS. GEMS are grouping symbols first, then evaluate all the exponents, then multiply or divide left to right, and then add or subtract from left to right. Okay. Again, this is where we see a ton of mistakes all the way up through calculus, AP stats, all that kind of stuff. So, you guys have done a bunch of these before. Let's take a look. Go ahead and pause the video. Go ahead and take a look at 2A and 2B. Pause the video now. Do those on your own, and then we'll check them. Okay, so you've unpaused. Let's take a look at 2A. First thing I'm going to do is I'm going to multiply 42 times 2, and I'm going to rewrite every time just to make sure I'm doing these correctly. So now I have 3 plus 84 minus 5, and then that's all addition and subtraction, so I just go left to right. 87 minus 5 is 82. And then here, I'm going to do exponents first, so 20 minus 7 plus 64 minus 7 times 11. Then I'm going to do the multiplication, so 20 minus 7 plus 64 minus 77, and then I'm just going to go left to right. That's all addition and subtraction. So 13 plus 64 is 77. 77 minus 77 is 0. That looks like a donut. Now I want a donut. Okay. When one or more grouping symbols is used, you start from the innermost and you work your way out. Again, you guys know how to work with parentheses, but here we have brackets and parentheses. And then we also have to know, and this is hugely important, sometimes we forget, that the fraction bar is considered a grouping symbol. So here we have to work the whole top, work the whole bottom, and then simplify at the end. Again, you guys have tons of experience doing this. Go ahead and take a second, pause the video here, see if you can get 3A, 3B, and 3C on your own. Pause the video now. So sometimes you've unpaused now. Sometimes we'll have answers or things like that from the notes that you're not sure about. The answer to 3A is 60. The answer to 3B is 10. The answer to 3C is 9. If you did not get 60, 10, or 9, try the problem again. If you do it again and you still don't get 60, 10, or 9, this is where in your notes you would make a star, asterisk, highlighter, some sort of hint to you to ask this question in class and make sure we get your question answered, okay? Let's take a look at example 4. Evaluating an algebraic expression is very simply, I give you an expression. Well, I'm not giving it. The book is. I guess I'm giving it to you. And then I'm telling you what x, y, and z all equal. You plug those in and you simplify. The key here is that you'll notice that when we plug the 4 in, for example, we plug into parentheses. Anytime you have an exponent or anytime there's sign error, by the way, is where we have a ton of mistakes. You want to plug in whatever the number is into parentheses so you don't make simple mistakes, okay? But again, this is just putting a number in and then simplifying as best you can until you get a number out. All right, go ahead and pause the video. Try 4A and 4B on your own. Pause the video now, please. Okay, you've unpaused. Let's get some answers. 4A is 23. 4B is 26. Again, if you did not get 23 and 26, go ahead and make some sort of highlight note to yourself so that we can go over those in class. All right? Let's take a look at real world example 5. This is just same stuff we've been doing, but now it's a word problem. But it's nothing new, okay? Nothing new. Take a look at the guided practice here. According to the California Department of Forestry, an average of 539.2 fires each year are started by burning debris, while campfires are responsible for an average of 129.1. Write an algebraic expression that represents the number of fires on average in D years of debris and burning, in D years of debris burning and C years of campfires. Okay, so we're just going to write an algebraic expression. That part's pretty easy. This would be 539.2 D plus 129.1 C. And you might not be able to see all that. Let me help you out here. There you go. How many fires would there be in 5 years? Well, what are you going to do? You're going to plug the 5 in for each one of those variables, right? And hopefully you're going to get 3,342. I mean, not hopefully. That's a lot of fires. But that's it. That's it for the notes on 1.1 and 1.2. Come to class with questions. If you don't have any, we'll get started with the practice next time I see you. This has been a lot of fun. I feel like the time we spent together was well spent. See you next time. Bye.